Hello everyone. Yesterday in the part 2 I completed this 2.1 exercise. So after that we have types of sets. Already I explained these types of sets in the introduction part of this part 1 in sets. So you just, if you have any doubts, you just look after that once, part 1 of my sets episode. So next I'll explain from the types of sets. Okay, already this I explained in the introduction part. So I want to enter into the do this in the page number 33. Okay, so look after here in the page number 33 we have do this, that is A is equal to set of, look at here, so page 33, do this. Okay, so in this, the first sum A, which has the elements 1 2 3 4, we have 4 elements in A. B is equal to 2 4, C is equal to 1 2 3 4 7 and 5. We know that it is a null set, so there is no elements in the set. So fill the blanks by using of this, fill in the blanks. It is the symbol which is used for the subset or not a subset, What do you mean by this subset? Subset means, here look after here, B have 2 elements, that is 2 and 4. Is these 2 elements is there in A? Yes, 2 4. Hence B is the subset of A. B is the subset of A. That means every element in B, every elements in B is belongs to A. Hence B is the subset of A. Right? You just recollect that definition of this subset. While doing these problems, you can understand in the better way. Okay? So what is the first one he was given in this one? That is A dash B. Is A is the subset of B? No. B is the subset of A. Here A is a superset. So only 2 symbols we have. Hence we have to use these 2 only. Hence it is A is not a subset. The fill in the blank. A is not a subset of B. Right? So second one, that is C dash A. C dash A. So is C is the subset of A? C is the subset of A? No. 1, 2, 3, 4 are the elements which belongs to A, but 7 is there in C. Hence it is not a subset of A. Not a subset of A. Here B, third one, that is B is a subset of A or not a subset of A. All the elements in B which is belongs to A. Hence it is a subset. Right? A is a subset of C or not a subset of C. All the elements of this A which is belongs to C. Look after here. 1, 2, 3, 4. These 4 elements which is belongs to C. Hence A is subset of C. Look after here in the fifth one, B. Is this B is the subset of C? Yes. Why? Because in B we have 2 elements, that is 2 and 4. These 2 elements are belongs to C also. Hence B is subset of C. Just like that. 5. Null set. In the introduction part I said to you, empty set is the subset of every set. Empty set is the subset of every set. So subset. I think you understand this problem. So second one, state which of the following statement is true. Is true. Right? It is empty set. It is a symbol of null set. Empty set, null set, void set, whatever you want, you can. Right? So it is empty set. Yes is equal to the symbol of null set. It was correct. This statement is true, right? 5 is not equal to 0. 0 is an element. 5 is a null set. There is no elements, but 0 is an element. Here also 0 is equal to, there is a 0 is the element in this set. So these two are not equal, right? Only this statement is true. Okay? Okay students, now try this. So in this try this first problem, just look up here. A is set of quadrilaterals. What do you mean by this quadrilaterals? Set of quadrilaterals, right? So A is equal to set of quadrilaterals means, so quadrilateral means which the figures have 4 sides. Which the figures have 4 sides. That means square, rhombus, rectangle, parallelogram, trapezium. Okay, so these all are 5. These 5 figures are quadrilaterals. So A is equal to square, rhombus, rectangle, parallelogram, comma, trapezium. How many elements we have? 5 in the set of A. And B is equal to what he was given here, square, rectangle, trapezium, rhombus, right? How many elements we have in B set? That is 4. State whether A is subset of B. State whether A is subset of B or B is subset of A. Justify your answer, right? So in the set A we have 5 elements. In set B we have 4 elements. In set B we didn't have this parallelogram, right? Parallelogram. But all the remaining 4 elements which belongs to A. Which belongs to A. Hence B is here all the elements of B belongs to A. Okay, hence B is subset of A. And also since A have more elements than B. Okay, so second one, if A is equal to A, B, C, D, how many subsets does the set A have? He was asking how many subsets, right? We have to find out the number of subsets for this set. So what is the formula for the number of subsets to find out the number of subsets? That is 2 to the power of n. In the introduction part of this part 1 of this sets, I said to you the number of subsets has to be found out by using of the formula 2 to the power of n. Number of subsets is equal to 2 to the power of n. What is this n? Number of elements. What is this n? Number of elements. So how many elements are there? 4. So n is equal to 4. So substitute this n is equal to 4 in this. So 2 to the power of 4. That is equal to 2 to the power of 4 means 2 has to be multiple 4 times, right? 4 times of this 2. So 2 twos, 4, 4 twos, 8, 8 twos, 16. 16 subsets. How can we write the subsets also? I will tell here. Look after here first. The first point, when you want to write the subsets of this any set, so first you have to remind one thing: every set is a subset of itself. Every set is a subset of itself. Means the same set we have to write here: A, B, C, D. Second point you have to remind, that is empty set is a subset of every set. Empty set is a subset of every set. That is equal to null set. These two are the subsets of everyone. That means every set is a subset of itself. Not this one. Itself. Empty set is a subset of every set. Right? So the first, then you have to write the single sets, that is A, then B, it is one of the subset, then C, then D, right? So 4 subsets, 4 elements, 4 singleton sets. So double sets, double elements, 2 elements, that is first AB, then BC, then CD, then DA, just like that you have to write, right? AB. So then AB, AC also we have to write AC, right? Then AD already we wrote here, right? So then BC, BD. So look after here. AB completed, AC completed, AD completed, then BC completed, then BD completed, then CD completed. Double elements completed. Now how many elements we completed? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 subsets already we completed, right? So 13th, now we have to finish off 3 elements. So A, B, C, 3 element subsets. So 14, B, C, D. 15, C, D, A. 16, D, A, B. Just like that you have to write all the subsets of a set. Okay, every time you have to just look after that. You have to find out the number of subsets by using of this formula, and if you want to write any subsets of a set, you have to write like this. Okay. Next, now here the answer is, in the textbook, here the answer is 16. Okay. Next, the third sum. P is a set of factors of 5. P is set of factors of 5. Factors means, what are the factors of 5? Only 1 is the factor of 5 and 5 is the factor of 5. That's it. P is equal to set of 1, 5. That's it. So Q is the set of factors of 25. Means, what are the factors of 25? In which tables it was divisor, right? So in 1 table, in 5 table and 25. That's it. So R is a set of factors of 125. So that is equal to, what are the factors of 125? 1, 5, 25, 125. Only these numbers are factors of 125. Okay, these are the sets. He was given in the words, we converted into listed form, right? Listed form. So he was asking that which one of the following is false. Which one of the following is false? We have to pick out the false statement from this 4. What is the first one? The first one is P is a subset of Q. Is it right? P have two elements, that is 1, 5. Is that two elements which belongs to Q? Yes, which belongs to Q. 1, 5. In the Q set also 1, 5 is there. Hence, it is true. The second option, he was given that Q is subset of R. Is all the elements in Q which is belongs to R? Yes. What are the elements which is present in Q? 1, 5, 25. Is this 3 elements which belongs to R? Yes. That's why Q is subset of R. Hence, it is also true. The third option, he was given that R is a subset of P. Is all the elements of this R belongs to P? No. Why? Because it has 2 more elements, that is 25 and 125. P have only 1, 5. Hence, R is not a subset of P. It is false statement. And the fourth option also, just I want to check it one. So P is subset of R. Is it was correct? Is all the elements of this P belongs to R? Yes. Why? Because 1, 5 belongs to R. Hence, it was true statement. So our answer is the third one. You have to write like this. Okay. Then fourth sum. So A is a set of prime numbers smaller than 10. Just convert these words into listed forms. Okay. A is the set of primes smaller than 10. Smaller than 10. Prime numbers. What are the prime numbers? 2, 3, 5, 7. There 11. But 11, up to 7 it is enough. Why? Because it is smaller than 10. So these are the elements which is present in A. So B is set of odd numbers less than 10. Less than 10. What are the odd numbers? 1, 3, 5, 7, 9. Less than 10 means we have to finish off up to 9. Right? 1, 3, 5, 7, 9. These are the odd numbers which is less than 10. C is equal to set of even numbers less than 10. As we know, that is even numbers are 2, 4, 6, 8. That's it. No need of to write this 10. Why? Because less than 10. So, put here. So, how many of the following statements are true? Just like the third sum. Just like the third sum, he was given some statements. So, we have to choose the true statements this time. Okay. The first statement, that is A is subset of B. Look after here. A have 2, 3, 5, 7. 2, 3, 5, 7. Right? So A belongs to B. Is all the elements of this A which belongs to B? No. So it is false. Okay, it was false. So second one, that is B is subset of A. Is all the elements of this B belongs to A? No. It is also false statement. Third one, A is subset of C. Is all the elements of A is a subset of C? No. It is also false. So fourth one, C is a subset of A. Is in the C we have the elements, that is 2, 4, 6, 8. Is all these elements which is belongs to A? No. Again it was false. Fifth one, B is subset of C. Is all the elements if this B belongs to C? No. False. So sixth one, C is belongs to B. C is subset of B. Is C elements all are present in B? No. Again it was false. So there is no true statement in the following given statements of the question. Okay. So students, we finished this page number 33. Do this and try this. Now page number 34. Okay, in the page number 34 we have think and discuss. Look after here. So in the think and discuss, he was given that is empty set subset to every set? Already I said no. Always empty set, null set is a subset of every set. Yes. Yes. Empty set is a subset of every set. Okay. Subset of every set. Second question, is any set subset to itself? Yes. Every set is a subset of itself. Okay. And the third question, you are given two sets such that a set is not a subset of the other. If you have to prove this, how do you prove? Justify your answer. What kind of sets we have to take? You are given two sets such that the two sets are not a subset of the other. Okay. If you have to prove this, how do you prove? So we have to take examples of these sets. So the third one in the page number 34, think and discuss, right? Think and discuss. So look at here. So two sets we have to take, that is A is equal to 1, 2, 3, 4 and B is equal to, the two sets are not a subset. So 3, 5, 7, 8. So here A set is not a subset of B and B set is not a subset of A. So these two are different sets, right? These two are not subsets of each other. So hence from above two sets, A is not a subset of B because all the elements of A which does not belongs to B, and also B is also not a subset of A. Why? All the elements of B which are does not belongs to A. Hence, these two are not a subsets. Okay, it is the solution you have to write for the third one. Then we entered into the page number 35. After this page number 34, so we have Venn diagrams on the union of sets and intersection of the sets. as well as the disjoint sets. In the introduction part, I explained to you about these three topics. So this time I'll explain the sums on these topics. Okay. So dear students, now we entered into the page number 35. In the page number 35, you have example 1 and 2, and also some more examples is there on the topic of this union of sets, intersection of sets and disjoint sets. I will explain now. So you just observe how we are solving this simpler and easier and enjoyable sums. Okay. So example 1, that is, let A is equal to 2, 5, 6, 8 is there here. B is equal to 5, 7, 9, 1. Okay. Find A union B. Union B. So A is there, given that A is there, B is there, right? You just write these two sets here. A is equal to and B is equal to. So what are the sets? What are the elements which is present in A, and what are the elements which is present in B? And to find out A union B, that is equal to 2, 5, 6, 8 union 5, 7, 9, 1. Okay. Union means all the elements which get together. Okay. All the elements in both the sets you have to write, but if there any element which is there in both the sets, you have to write it once. Okay. So 1, 2, 5 is 2 times here in both the sets, you have to write only once, and 6, 7, 8, 9. All the elements which belongs to both the sets you have to write here. But if any element is repeated, only once you have to write here. That is union. Okay. It is very easy, you know. Right. Example 2. So A is equal to what he was given here. Look at here. Let A is equal to AEIOU, B is equal to AIU. Show that A union B is equal to A. Right. So given that A is equal to A, E, I, O, U. These are the vowels, and B is equal to A, I, U. Here just look after this. This B is a subset of A, right? Why? Because all the elements in B which is belongs to A. Hence B is subset of A. When you find out this A union B, what is the answer we will get? We will just look after here. So A, E, I, O, U. Union. So here A is repeated in both the sets. Only once I am writing here. So E. So I is repeated again only once. O. U is repeated. So only once you have to write. Right? So A, E, I, O, U. Which set it was? A. That is equal to A. Hence, A union B is equal to A because B is subset of A. Okay? Right. Next, example 3. Example 3. Look after here, example 3. If A is equal to 1, 2, 3, 4, B is equal to 2, 4, 6, 8, find A union B. Right? Very easy. Right? Given that A is equal to 1, 2, 3, 4, B is equal to 2, 4, 6, 8, A union B is equal to 1, 2, 3, 4, union 2, 4, 6, 8. So all the elements you have to write in this union, right? So 1, 2, 3, 4, 6, 8. By using of this Venn diagram, he shown this problem. Okay, how? So Venn diagrams, we know that in a rectangular form we are taking it as mu, that is universal set. Already in the introduction part I said to you that is Venn diagrams is the universal set is identified by using of these rectangles, and whatever you want you can take in circles, ovals or triangles, right? So this is A set, this is B set. First of all, in both the sets, what are the common elements? What are the common elements? 2 and 4, right? That 2 and 4 you have to write here. Common elements. After writing of these 2 elements in this portion, what are the remaining elements in A? 1, 3. You have to write like this. What are the remaining elements in B? 6, 8. So total all together you will get A union B. That is equal to, what are the elements of all? That is 1, 2, 3, 4, 6, 8. Just like this. It is one kind of method, and it is used by using of this Venn diagram. You can solve any one, right? This one, right? So up to third example we will finish this union problems. Enough intersection problems. Okay, example 4. Given that, find A intersection B when A is equal to 5, 6, 7, 8, B is equal to, given that A is equal to 5, 6, 7, 8, B is equal to 7, 8, 9, 10. How can we find out this A intersection B? So, the elements of this A, first write here, intersection 7, 8, 9, 10. So, intersection means the common elements only you have to write in this set. What are the common elements? In both the sets, the elements has to be belongs, which is present in this both the sets. So, 7 is there in both the sets. 8 is there in both the sets. Only that's it. That is intersection, right? Okay. Then example 5. So A is equal to 1, 2, 3, B is equal to 3, 4, 5. Then find A intersection B in Venn diagram. Okay. So A is equal to, given that A is equal to 1, 2, 3, B is equal to 3, 4, 5. So A intersection B is equal to 1, 2, 3, intersection 3, 4, 5. What are the common elements present in both? Only 3. That is the answer. By using of this Venn diagram, how can you write? The common elements only you have to write, right? So it is universal set, mu, it is A, it is B. A set, B set. First of all, look after here these two. What are the common elements? Only 3. 3 you have to write like this, like here. So remaining elements 1, 2. Here remaining elements 4, 5. Intersection itself. Intersection means, what is intersection? Only the common elements you have to choose. So 3. So by using of this Venn diagram, A intersection B is equal to only 3 is the element in this set. Okay. Then after this example 5, in page number 37, you have do this, try this and think and discuss. We will complete these 3 now. Okay. In do this, page number 37. I think you will understand in the better way, maybe. I hope you can do it by yourself, but I'll explain once. You just look after here. So first sum, given that first sum solution, A is equal to 1, 3, 7, 8. B is equal to 2, 4, 7, 9. So A is equal to 1, 3, 7, 8, B is equal to 2, 4, 7, 9. So we have to find out A intersection B. So A intersection B means 1, 3, 7, 8 first sets you have to write. So intersection 2, 4, 7, 9. What are the common elements in both the sets? This 1 is there, 3 is there. Just look after keen with the keen observation. So you have only one element, that is 7, right? There is no common elements, only one, that is 7. It is a solution for the first sum. So second sum, so if A is equal to 6, 9, 11, okay, given that A is equal to 6, 9, 11, 6, 9, 11. So phi is equal to empty set. Already we know that phi is equal to empty set. You have to find out A union phi. What is A? 6, 9, 11. Union phi means empty set. Union means you have to write all the elements. There is no elements. Only the A have 3 elements. You have to write that 3 elements. It is the final answer. That is equal to A, right? So A union phi is equal to A. It is one of the formula. Okay, one more thing you have to write, you have to prove here in this sum, that is second one, that is A intersection phi you have to find out. That is A set, that is 6, 9, 11. Intersection null set. What are the common elements present in these two? There is no elements in this empty set. Hence there is no common elements. So the final answer you will get is empty set, that is phi. So here we get another formula, that is A intersection phi is equal to phi. It is one of the formula, right? So third sum now. So given that A is equal to set of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. B is equal to 2, 3, 5, 7. Find A intersection B. Find A intersection B. What are the elements in A? Intersection B. 2, 3, 5, 7. Intersection means the common elements in both the sets, right? What are the common elements? 2 is there, 3 is there, 5 is there, and 7. That's it. What is 2, 3, 5, 7 set? Which set it was? B. That is equal to B. Hence A intersection B is equal to B, because B is subset of A. So already he was given that, show that A intersection B is equal to, hence it is proved. So fourth sum, if A is equal to 4, 5, 6, if A is equal to 4, 5, 6, B is equal to 7, 8. We have to show that A union B is equal to B union A. First of all, you just find out A union B, that is equal to 4, 5, 6 union 7, 8. What do you mean by this union? All together 4, 5, 6, 7, 8. Just like that you have to find out B union A also. 7, 8 union 4, 5, 6. So all together you have to write here 4, 5, 6, 7, 8. So both the sets are equal, hence the given A union B is equal to B union A. Hence it is proved. So in the page number 37, do this is completed now. Now try this. Same page, try this. So the first sum. So in the try this first sum, you have to write by your own. That is, you have to choose two sets, that the elements which does not belongs to each other, right? And at the same time, A and B has to be disjoint. I will write two examples here. You can write by your own. Okay. List out some sets A and B. Choose their elements such that A and B are disjoint. Means just one example I am giving here. That is, A is equal to 1, 2, 3. B is equal to P, Q, R. Is any elements are same in this both of the sets? No. Hence, A and B are disjoint sets. Okay. Disjoint sets. A and B are disjoint sets. Why? Because no elements is same in both of these sets. Okay. Just like that, you may give more examples on this sum. So second sum. That is, A is equal to, given that A is equal to 2, 3, 5. Then find A union 5. 5 means null set. Already we know that 5 is null set. There is no elements in null set. That is equal to A means 2, 3, 5 union empty set. Union means all the elements we have to write from the both the sets. So there is no elements in null set. We have to write these elements remaining. So 2, 3, 5. That is equal to A. So A union 5 is equal to A. So second, he was given that 5 union A is equal to, 5 means null set, union A means 2, 3, 5. So all together we have to write 2, 3, 5. Again the answer will get same, that is A. So A 5 union A is equal to also A. So from equation 1, 2, you will get A union 5 is equal to 5 union A is equal to A. Okay. Then third sum. Here A is equal to 1, 2, 3, 4. A is equal to 1, 2, 3, 4. B is equal to 1, 2, 3, 4, 5, 6, 7, 8. Then find A union B, A intersection. What is a result you may notice? So hence A union B means, firstly A union B. Here just once look after, A is a subset of B, right? From the sum, from the above, A is subset of B. All the elements of this A belongs to B. So A union B means, A means union so all the elements you have to write. So 1, 2, 3, 4, 5, 6, 7, 8. So it is a set of B. So A union B is equal to B. If A is subset of B. If A is subset of B. So already also we have to find out A intersection B. It was first one, it was second one in third problem. So that is A 1, 2, 3, 4 intersection 1, 2, 3, 4, 5, 6, 7, 8. So that is equal to, intersection means the common elements only we have to choose. So 1, 2, 3, 4. So which set it was? A. Hence A intersection B is equal to A if A is subset of B. If we have union, if A is subset of B, then we get the final answer as B. If A is subset of B, If it is intersection, you will get the answer as A. Okay, that you noticed from this sum. That you noticed from this sum. Third one. Okay. So fourth one. That is fourth sum. A is equal to 1, 2, 3, 4, 5, 6. B is equal to 2, 4, 6, 8, 10. What he said? Intersection of A and B. A intersection B. What is A? 1, 2, 3, 4, 5, 6. Intersection 2, 3, 2, 4, 6, 8, 10. So what is the intersection? Means common elements you have to choose. 2 is there common. That is 2. The common element, another common element which was 4. 4. Another one 6. That's it. That is the answer. Okay. Now, the next one is think and discuss in the same pace. That is page number 37. Okay, think and discuss. The intersection of any two disjoint sets is a null set. You have to choose by taking another sets by its own. Okay, the intersection of any two disjoint sets. We have to write two disjoint sets. Let us take, so think and discuss solution. So let us, two disjoint sets are A is equal to X, Y, Z. B is equal to P, Q, R. So we have to find out the intersection of these two disjoint sets. No elements is same in both of these sets. So we have to do the intersection. Intersection means A intersection B is equal to X, Y, Z intersection P, Q, R. What are the common elements? We have to choose out the common elements of both of these sets, right? There is no common elements. What we will get? Null set. That is empty set. A intersection B is equal to null set if A and B are disjoint sets. Okay? That is justification of this answer. It is a solution for this think and discuss. Now we entered into the next phase, that is 38. In the page 38 we have example 6 in page number 38. Example 6. Let, what is the solution? What is he was given here? So A is equal to 1, 2, 3, 4, 5. B is equal to 4, 5, 6, 7. It is a sum which is a related sum to give the difference of these two sets. Okay, that is A minus B you have to find out. Till now, you know about the union and intersection. Now it is a sum which is related to difference of any two sets. That is A minus B. How can we find out this kind of sums? So A means, what is A elements here? 1, 2, 3, 4, 5. Minus 4, 5, 6, 7. Here from the A set you just strike out the B elements. What are the B elements present in A? Is 1 is there? No. 2 is there? No. 3 is there? No. 4 is there? Yes. So strike out that. So 5 is there? Yes. Strike out that. And leave these B elements. Leave these B elements. Only write the remaining elements which is there in A. It is A minus B. Okay, it was the answer for this sum. I think you understand this one, right? So it was the solution. If you want to know B minus A, here he did the B minus A also. So you just look after here B minus A. If you did this sum, is you will get the same answer or not? Once you will check. Okay, we will check. So 4, 5, 6, 7. minus 1, 2, 3, 4, 5. This time we just strike out the numbers from B. So we just choose the numbers which is belongs to A. So 4 is there in A, so you just strike out. 5 is there, strike out. You just leave this A. Only write the remaining elements in B. So 6, 7. Is 2 answers are same? No. So never be equal to if there is a different elements A minus B is not equal to B minus A. Okay. From the Venn diagram also he did this sum. Just look after here. No need of writing of this sum by using of this Venn diagram, but once check. Okay. Next, that is do this. In the same pace we have do this, that is page number 38. The first sum, that is if A is equal to what he was given here, A is equal to 1, 2, 3, 4, 5. B is equal to 4, 5, 6, 7. So A minus B you have to find out, and also you have to check B minus A also. Is they are equal? You have to conclude that answer in this sum, right? First of all, you have to find out A minus B. That is 1, 2, 3, 4, 5 minus 4, 5, 6, 7. So you have to strike out the elements which is belongs to B, right? 4, 5. You have to strike out from this. So only remaining we have 1, 2, 3. So A minus B is equal to 1, 2, 3. And we have to find out this B minus A also. So B minus A, that is equal to B elements are 4, 5, 6, 7. Strike minus A 1, 2, 3, 4, 5. And just strike out the elements which is belongs to B. Only we have 6, 7. And from the both of these two, so A minus B is not equal to B minus A. Just above sum, right? So second sum, when they do this, let given that V is equal to A, E, I, O, U and B is equal to A, I, K, U. So you have to find out V minus B. A, E, I, O, U minus A, I, K, U. You just strike out the elements which is belongs to B, that is A, I, U. How many elements which is remaining in this first set? E and O. That's it. B minus V. A, I, K, U minus A, E, I, O, U. You just strike out this one. I, U. Only we have K. So from here, B minus B is not equal to B minus B. That's it. So think and discuss in the same pace. The sets A minus B, B minus A and A intersection B are mutually disjoint sets. Use examples to observe if this is true. Use examples to observe this is true. Okay. So in this we have to take two sets, that is disjoint sets, that is A is equal to, let us take A is equal to PQR, B is equal to ABC. Okay, these two are disjoint sets, right? No elements is same in both the sets. So first of all we have to find out this A minus B. What is A? PQR minus ABC. No elements is strike out from this first set. No need of this striking. Why? Because there is no common elements in these sets. So hence we have to write these all elements of this first and leave this one only P, Q, R, right? It is the answer for A minus B. B minus A now. A, B, C minus P, Q, R is equal to. So no elements is same. So we have to write A, B, C. So B minus A answer is this one. Next we have to find out A intersection B also. What is A? P, Q, R. Intersection A minus A, B, C, right? So A intersection means the common elements has to write in this set. Is there any common elements? No, empty set. So A intersection B is equal to 5. If we take any two disjoint sets, A minus B answer will get different than B minus A and A intersection B. So look at here. Mutually disjoint sets A minus B, B minus A and A intersection B are mutually disjoint sets. Use examples to observe if this is true. Yes, these are. Here you have to conclude here after completion of this sum. Yes, these are mutually disjoint sets when we are taking any two disjoint sets. Okay. Next, after this we have exercise 2.2. The first sum. Here it was given that A is equal to 1, 2, 3, 4. B is equal to 1, 2, 3, 5, 6. Find A intersection B, B intersection C. Are they equal? Let us check. So given that A is equal to 1, 2, 3, 4. B is equal to 1, 2, 3, 5, 6. So A intersection B is equal to, what is A? 1, 2, 3, 4. Every time you have to write like this. In the exam point of for the exam point of view, you have to write like this. Just to habituate. Okay. So A intersection B means 1, 2, 3, 5, 6. So that is equal to. What are the common elements? Intersection means we have to write common elements. What are the common elements on both the sets? 1, 2, 3. And also you have to find out B intersection A. First B you have to write 1, 2, 3, 5, 6. Intersection 1, 2, 3, 4. So what are the common elements in both? 1, 2, 3. Is they are same? Yes. A intersection B is equal to B intersection A or equal. It was the solution for the first sum. Second one. A is equal to, given that. Okay. Comment. We have to comment on these two. A intersection 5, A intersection A. First, we will write the given that A is equal to 0, 2, 4. What is 5? It's a null set. No elements. So first of all, we have to find out A intersection 5. What is A? 0, 2, 4. Intersection, null set. What are the common elements in both the sets? No elements. So it is 5. So next, what you have to find out? A intersection A. What is A? 0, 2, 4. Intersection 0, 2, 4. What are the common elements? All are common elements. Why? Because these two are same sets. So 0, 2, 4. So A intersection A is equal to A1. Here A intersection 5 is equal to 5. Here it was a comment. Okay. Next, third one. So here two sets was given here. So we have to find out A minus B, B minus C, right? So given that A is equal to 2, 4, 6, 8, 10. B is equal to 3, 6, 9, 12, 15. Okay, we have to find out A minus B. What is A? 2, 4, 6, 8, 10. Minus B means 3, 6, 9, 12, 15. So minus means you have to strike out the elements which belongs to B, right? Is 2 is there? No. 4 is there? No. 6 is there? Yes, strike out. So 8 is not there, 10 is not there. The remaining elements in A you have to write as solution. And leave this B. This is A minus B. Okay. Then you have to find out B minus A also. B minus A. What is B first? 3, 6, 9, 12, 15. Minus 2, 4, 6, 8, 10. So you have to strike out the elements which is present in A, right? 6 is there, you just strike out it. Is there any elements is there? No. So you just write all the remaining elements in this. 3, 9, 12, 15. It was the solution. Is A minus B and B minus A are equal? No, these two are not equal. A minus B is not equal to B minus A. It was the solution of this third sum. Fourth sum now, if A and B are two sets such that A is subset of B, the condition is given that the condition is A is subset of B. A is subset of B. Just like that. By satisfying this condition, you have to take the sets. Let us. A is equal to AB. B is equal to ABC. Is the condition was satisfied? Yes. A is a subset of B now. Right? Now you just find out A union B. A union B. That is equal to A is equal to A comma B union A B C. So what is the final answer? All the elements you have to write here A B C. So that is equal to A B C set is B. If A is subset of B, then A union B is equal to B. It is the solution of this fourth sum. Now we entered into the next phase, that is fifth sum. He gave the set of A, B, C, D are in set builder form, right? You have to convert this into the roster form, that is listed form. So you just look up here, A is equal to X colon X is a natural number which starts from 1, 2, 3, 4, right? So I am writing here the sets. So that is A is equal to natural number. So all the natural numbers, X colon X is a natural number. Hence A set is 1, 2, 3 and so on. And so on also you have to write. Don't leave the end, the last element we didn't find. So that is infinite. So B is equal to X colon X is an even numbers. That is even numbers which starts from 2, 4, 6 and so on. And C is equal to X colon X is an odd numbers. That is equal 1, 3, 5, 7 and so on. D is equal to X colon X is a primes. That is equal to 2, 3, 5, 7 and so on. Okay, these are the sets. Then you have to find out this A intersection B. Intersection means the common elements you have to choose from these two sets, right? I think so many examples I said to you and so many do this, try this, all we did here. So I think you will do this problem, right? You just do it and final answer you just comment it. Okay, A intersection C, you just do it. All the sums in fifth sum you just do by your own and the final answer you just comment me. Okay, this fifth sum. Next, sixth sum also is just like that. So sixth sum we have sets. It is given that A is equal to 3, 6, 9, 12, 15, 18, 21. B is equal to 4, 8, 12, 16, 20. C is equal to 2, 4, 6, 8, 10, 12, 14, 16. And D is equal to 5, 10, 15, 20. I think you can do these sums, A minus B. I'll show one sum. Remaining sums, the final answer you just comment to me. Okay. So A is equal to 3, 6, 9, 12, 15, 18, 21 minus, what is B? 4, 8, 12, 16, 20. You just strike out the elements which belongs to B, right? Is 4 is there? No. Is 8 is there? No. Is 12 is there? Yes. Strike out it. Is 16 is there? No. Is 20 is there? No. You just leave this B and remaining the elements you just write here. 3, 6, 9, 15, 18, 21. It is the answer for this A minus B. Just like that, you just do the all sums in this Roman. Okay, A minus B. Finally, you will get one answer. No. You just comment me in my comment box. Okay, just 7 sum. Now we entered into the 7th sum. State whether each of the following statement is true or false. Justify your answer. You have to write the true and false. And also you have to write the justification of this problem. The first one, he was given that 2, 3, 4, 5. One set, and the another set is 3, 6 or disjoint sets. Is it true? Is there any common elements is there? Yes. 3 is there, right? No. These two are not disjoint sets because 3 is a common element. That's it. That is the answer. Second one. A-E-I-O-U and A-B-C-D. Is it true, the first one? The first one is true? No, it is false, right? So, it was false. So, here in the second sum, A-E-I-O-U and A-B-C-D or A-B-C-D. These two are different sets or disjoint sets. Is these two are disjoint sets? Is there any common elements is there? Yes, A is there. So false. No. These two are not disjoint sets because A is a common element. Okay. Third one. 2, 6, 10, 14 and 3, 7, 11, 15 are disjoint sets. Is it true? Is there any common elements is there? No, right? True. Yes, these two are disjoint sets because no common elements is there. Right? Fourth answer. That is 2, 6, 10 and 3, 7, 11 or disjoint sets. Is there any common elements? No. Yes, these two are disjoint sets. True. Yes, these two are disjoint sets because there is no common elements. So we finished this 2.2 exercise. I think children, you understand in the better way. Maybe నేను అర్థమైనవి అనుకుంటున్నాను. So నెక్స్ట్ రేపటి ఎపిసోడ్లో రేపటి పార్ట్లో నేను పార్ట్ 4లో 2.3 అండ్ 2.4కి సంబంధించిన సమ్స్ అన్ని కూడా మీకు ఎక్స్ప్లెయిన్ చేస్తాను. ఓకే, థ్యాంక్ యూ.